associated with different pandemics. This group out here, which has a lot of samples on it, is associated with the third pandemic. Not to go into too much detail, but when you see a bubble on the backbone there, that's a collapsed branch because we haven't done whole genome sequencing there. We've only genotyped it with our canonical SNPs. So those are the genomes that we've sequenced, and so from those, then those are the tips of the branches. One important point about this tree is the basal radiation for all of these branches is in China. And so the evidence is growing very strong. In fact, Yersinia pestis has grown in China. It originated and evolved in China. Then it's emerged out of China again and again and again in these pandemic type waves that have been sweeping around the globe for almost 2 millennia, perhaps longer than we even know. And I'll show you some evidence for that now. Now, one of the fun things to do then is to go back and look at these phylogenetic groups and try to figure out where and look at where they occur geographically, and then try to match the phylogeography to that. And so, for example, this one group, there's some evidence based upon a very simple phylogeny, in fact, that it matches up with the Silk Road, with the ancestral nodes back in China, and then more derived as you move out. Likewise, we can do this with other ones. This particular branch has been postulated to be associated with Xin He, the navigator, who was the Chinese navigator, who in the 15th century sailed across much of the Indian Ocean, including bringing back a giraffe and a zebra back to the court in Beijing. So now, one of the things that we almost never get to do is go back and look at the ancestor for these, but that's starting to happen now. Ancient DNA techniques have come a long ways, and it's possible to even go back and completely sequence genomes of bacteria that have killed people. So I'm going to tell you about 3 different studies that have now come out. So this is a paper that came out where they reconstructed how plague moved across Europe. This was during the Middle Ages. And so they got into England in the 14th century, here in the 14th century, Italy, the 16th and 17th century. And I'm going to tell you about some genotyping efforts that we've done here in this part of England and also here in the Netherlands. So samples from these locations were analyzed using canonical SNPs, so canonical SNPs based upon, again, the phylogeny of Yersinia pestis. And then I'm going to tell you about an analysis that we've just completed and just published in the last couple of weeks on Bavaria from the 6th century. So this would be the Justinian plague, whereas these would then be the second, or the Black Death type analysis. Here's the phylogeny of Yersinia pestis for the global population structure. And what we see then is that we have canonical SNPs. Again, these are PCR, very low-level detecting genotyping tools that we can put at these locations. The samples from France and England fall in the branch right here.